In my last video, I went over a Voron Zero build I did, but I never elaborated on why I bothered. So, why did I build a Voron Zero? The Voron I built is a parts printer. It is specifically designed to 3D print parts for other 3D printers. But why not just use the Voron as my main 3D printer? Well, it's small. It's a very small 3D printer. It has a whopping 120mm by 120mm by 120mm build size, which is 12 centimeters, which is about a third of a foot. Yeah, it's not very large. It's not good for anything but little trinkets and bips and bobs and maybe chip clips or something. So, what exactly am I trying to make with it? Well, we're going to be making this. The CR10NG v1.2Core XY conversion. What exactly is the CR10NG? Well, it is a user mod by Puppy for the Ender 3NG, which converts old Ender 3 3D printers, being the Ender 3 Original, the Ender 3 Pro, and the Ender 3 S1, into Core XY printers that are on par, if not potentially slightly better, than Vorons. The Ender 3NG is massively customizable, leading to many configuration options. You can customize everything from how the frame is built, to if it has an enclosure or not, to how the bed's held up, to using a 3D printed custom CNC'd or the stock Ender bed, what type of wobble compensation, how many motors you want to use, what kind of screws, power supply widths, what boards, what hot ends, what extruders, which cooling, I mean, there's even a CPAP option. It's absolutely insane, and you can use almost any probe you'd like. This 3D printer was specifically designed to let you do basically whatever you want, and depending on how much you're willing to spend, you could have a truly Lamborghini-esque 3D printer. So why build this specific version, the CR10NG? Well, the reason I like to go with is I love challenges, and Vorons are just too well documented. The real reason is I don't have an Ender 3. All I have is a shitty old 2017 CR10. Like the OG one, where all the electronics are separate from the frame. If you remember those days, you're an OG 3D printer guy. But anyways, I got bored of looking at it, and it's only good for PLA and its stock configuration, so why not do something kind of special with it, right? The good thing about this project being based off the E3NG specifically means it still follows all of these configuration options. It requires a little bit more custom fabrication, because obviously the sizes are very different. This is an Ender 3NG, this is the CR10NG theoretically. This is a big old boy, boasting a whopping 300 by 300 by 400 build, compared to the Ender 3's 235 cubed. That's an insane difference, and it leads to some interesting options we have to take for configuration specifically. If you take a look right here under the frame option, you will see that there's 3 different options for the frame. There's printed verticals, which is really good if you just want a cheap little 3D printer. It is a cheap option. It's not the best, obviously, but it works. It works pretty well, actually, for Ender 3s. There's a 2040 upgrade, which is this one right here, that adds 2040s in the back to give a little bit more rigidity. And it's basically the middle ground. It's really good for the price, best price performance, but there's this little thing called physics. And boy, is physics a bitch. So where does physics play a role here? Well, physics says that if something is a lot taller, it likes to wobble more. Hence, buildings in New York City's having compensation weights. There are weights in the buildings that actually move to keep it from wobbling too much. The same thing is applicable here, minus the moving weight thing, because those are millions of dollars, and I'm not doing that, obviously. This will have more wobble, which can cause bad textures on prints, or even prints to fail sometimes. So for our configuration options, we are a little limited, unfortunately. We have to use the ultimate frame, which is the most expensive. Unfortunate, but completely expected. We have to use all 3 rods. Gotta have all the rods. Again, just to help with rigidity. And for Z-wobble compensation, you have to have it. Mostly, this part isn't really because of the physics, honestly. It's more of the lead screw on the CR10 is so old, there's no way it's not bent. It's one lead screw holding the entire X gantry up. It's 100% bent. And even if you buy 2 new ones, it's still better to have the compensation. Unfortunately, I'm going to have to custom build this part. Yeah. Because on this right here, this is the only option that's for the CR10NG. It's flexi joint. Basically, you 3D print this out of TPU, this little piece right here, and it kind of sort of does what this does, but, you know, with flexible materials. But I want to use this. If we already have 100 extra millimeters of height, why not lose some to get the best wobble compensation we can get? Wobble X is, it uses ball bearings and little pinion rods to actively move this entire piece right here to make sure even if the lead screw is bent all out of whack, I'm talking you can see the curve. You can have back bent more than when in bed. It will still leave the bed straight. You will not even notice it unless you look really hard. And for the Z-axis drive, the only configuration option we have available is the one-stepper option, which is fine because bed tramming really scares me. I'm really scared of bed tramming. Like with multiple motors, kind of like on the Voron 2.4, that scares me. We also have to buy a brand new power supply because the one in the CR10 is 1, 12 volts, which isn't good enough, and 2 is not either of these standard sizes. But now we get to move on to the fun part. All the little gicks and gooks and gadgets we're going to use. So, what are we going to use here? Well, for the board, we're going to use the BTT Manta M5P. Why the Manta M5P? Well, I'm glad you asked, even though you probably didn't, because we all know why. Instead of having to have a separate Raspberry Pi on these DIN rails that'll be in the back, I would show you pictures, but I don't have any right now, and it's going to look different on ours anyways, so you'll see it in the build video. Better come back for it. Anyways, usually with these 3 boards here, you have to have a separate Raspberry Pi. And I don't really want to do that, especially because I just so happen to have the top line Compute Module 4 sitting in my house doing nothing. I'm talking 8 gigs of RAM, 32 gigabytes of onboard storage, and Wi-Fi capabilities all on my Compute Module 4. So we're going with the M5P because it has all the features I want and supports the Raspberry Pi Control Module 4. Compute Module 4. Editor, cut that out, please. Moving on to the tool head. For our hot end, we're going to be using the Revo Voron. The 3D printer I'm building here needs to be my daily driver 3D printer. It needs to be able to do anything and everything I ask it to. Any filament, any material in the filament, any type of that material, the filament. There's tungsten filaments out there, people. We got to do some excellent stuff. So I need to be able to change nozzles on the fly with no issue. The Revo Voron boasts its toolless nozzles, where you can simply grab them, twist, take them out, put them back in, and twist. And you've got a brand new nozzle on there. But what are we going to use to push the filament through this extruder? We're going to be using the Proto Extruder 2.0. Running on the HGX 2.0 Lite gear set, it has a reduction ratio of 44:10 to 37:17, depending on the amount of teeth on your stepper motor. It has a large amount of contact on it, on the filament, because of how big this little area here is. And of course, it's $20. If you have a 3D printer, it's $20. So it's a great option because it's a perfect mix between price efficiency and power. For the part cooling, we're simply going to be using 2 4010s. And I'll tell you why we're going to do that later, because there's a reason why I'm just using the basic cooling. It's not super important right now, but it will be later. And for our bed probe, the Voron hot end that we're getting has the PC probe built right into it. So, it can simply do the Voron tap. Tap the bed with the nozzle, and that'll work perfectly for our leveling. For our accessories and mods, the accessories right here are specifically for the hot end, for which we'll be using the BTT Manta EBB36 hot end breakout board. It simply moves all of the ports that you need for the hot end to the hot end instead of having to run wires all the way down the back of the printer into the boards. It's all right there, and one singular wire goes to the back to control everything. For mods and upgrades, we're going to be doing stepper cooling because I want this thing to be fast when it needs to be. Right here, these frame braces, you'd think me talking about blibbity bloobity bleh, need frame rigidity, wobble, but actually, you don't want these because we're going to be using the enclosure. And the enclosure is, it says right here, the enclosure is superior in the rigidity. So these would literally do nothing. It's not like a thing where it like stacks, like you have the braces and the enclosure, because if the enclosure's already taking all the stress off of what the frame braces would do, the frame braces aren't going to change anything. We're obviously going to grab handles, because I am a college student and I will be moving around a bunch. We're going to have all the LEDs. We want to be able to see our beautiful, beautiful prints as they're happening, and I have a camera solution lined up that I think you're going to really enjoy. For our auxiliary cooling, you know we're getting auxiliary cooling. These use massive, and I'm talking massive, 120 millimeter by 32 millimeter blower fans to blow air over the build plate. That's why I didn't bother with enhanced cooling on the hot end. If I wasn't using the auxiliary coolers, I'd go with the 5015 or the 4020. I don't mess with CPAP personally, but that's just because I don't care to have it the whole time I'm trying to print something. For our bed, we're going with an AC bed with WAGO connectors to make it really easy to just flip a switch and take them off. Easy peasy. We're also going to grab the underbed fan to heat up the enclosure faster. And I'm not fully sure on the Auto Z yet. I'm going to look more into it, and I will tell you on the next video where we start printing and sourcing all the parts, if I'm going to go with it or not. Another good thing about the Ender 3NG is you get to 3D print most of the parts, which means you get to pick the colors. And right now, this right here is the color I'm going with. This is not how it will turn out. This is simply a rough estimate. But the wonderful rh3d.xyz website gives you all this configuration, the configuration for their new 3D printer, which I may touch on later, and this wonderful color scheme thing. So say I just want to test out, oh, well, would blue look good? Well, I can go over here and got blue. I need to come over here, which I thought about doing this because it looks like the original CR10, but I used a very, very, very in-depth technique to find out the colors, which there will be a picture of right now. Thank you, editor. But this tool helps you get an idea of what the colors would look like. They won't turn out like that because it also depends on your filament and 3D printer and, you know, all the things. But the colors we went with that you saw earlier, I think will look good. And for the filament we're going to be using to be 3D printing all this stuff, it is the Atomic Filament. Atomic Filament is a USA company. They make all different types of filaments. Most known for their wonderful carbon fiber filaments, which we will look at right here. They have them in all shapes and forms: nylon, ASA, PETG, PCTG, which is really new. If you don't know about PCTG, look it up because it's super cool. But the specific colors we're going to be using today are Perfect Red and Light Gray, which there's some really cool ABS options. I mean, you got your normal black and white, but you also have Perfect Blue, Orange, Army Green, Neon Yellow, which looks really cool, and I'm thinking about using on another build, Neon Green, and Dark Cherry Red. This would have absolutely been the filament I got had they had it when I was going to do this, but they didn't. They also have natural ABS. This is what it looks like when it comes out extruded. Very cool. That is all for our configuration today, which also means it's all for our video. Every website I showed you will be linked in the description so you can take a nice look at them. And I hope to see you for the next video where we process all the parts that we need. So, that's 3D Mayo. Out.